The idea of this talk is DevOps to platform engineering, evolution of a tech enterprise, and I will kind of explain a little bit what that means. Very brief about me, I have been doing this for roughly 14 plus years. Right now, I lead a platform engineering team globally across 5 to 6 countries in a big four consulting organization. I am also a platform engineering ambassador, a DevOps Institute ambassador. I'm part of the CNCF Platforms Working Group. And just like Prem is doing here, I also run some meetups. I basically chair the HashiCorp user group and the Docker user group in Kolkata, my hometown. This is just a disclaimer. This is just to save me from the lawyers, right? Because so this is I'm speaking on my own behalf, nothing to do with any company stuff. Okay, guys. So let's start, right? So there are three sections, very simple. Section one is an introduction to DevOps, because just to set the context, right? So that we are all speaking on the same thing. Section two would be something else, which is platform engineering, which is what I do, is what I hope some of you would like to do after this session as well. And finally, kind of a comparison, right? What is what, right? Kind of demystifying everything. So what is DevOps? I think this was in 2000, there was an O'Reilly Velocity conference. I don't know if any of you have seen the video. That's when the DevOps term was coined, right? So you can understand how long back. So today, if you ask somebody, okay, man, what is DevOps? He will say, oh, I have a GitHub repository. I do a CI/CD pipeline. I create a package. I deploy it onto something, right? So I'm a DevOps engineer, which is true also. To be very fair, that's how the industry is seeing. But originally, it was not like that. If you see that original video where DevOps term was coined, it's enlightening. It's on my LinkedIn thing. So you can also check, or you can reach out to me. I can share you the link. So DevOps originally was the concept that the development and ops team don't really talk to each other normally, right? It's like, okay, the developer has done the stuff. They are shifting it to ops. Ops is saying, no, your stuff is shit. I'm shifting it back to you, right? That's what the whole thing was. And DevOps was more of a cultural change. And to do that cultural change, you needed tools, right? Just by talking, you cannot have culture change. You need a tooling system, many things to do that. So that's what DevOps essentially was. Obviously, it was a lot of focus on collaboration, communication. If you've read some of the books like Velocity, Accelerate, I think you should read, then you kind of get the full picture of DevOps. But obviously, DevOps also is tools, right? And that's what, when you go to an interview, you have to know some of this, right? You cannot just say, I know I have a very good culture. I can help you with the culture of your team. They will say, okay, come back sometime later, right? So that is the thing. So, and this is the most important thing, right? If you see, it's Dev and Ops. So the tools are not only for developers, right? So the developer will obviously code, push it using some sort of a CI/CD pipeline, put it into artifact management system. Then some of the awesome stuff that the past speaker was talking about, right? The observability, everything is needed. As you can see, Rapana is shown here also, right? Somebody was showing, I think. So all of this is needed to kind of come to DevOps. And with DevOps, this idea came that, okay, now that I am this combined team, right? I have a developer, I have an ops, everybody is very closely knit. Then if I build it, I will run it. That was Werner Vogels used to say, right? Amazon used to run on this principle that there is no separate ops team, there is no separate dev team. You have built it, you run it in production. So there is, if something breaks in production, you don't have any ops team to call. No, L1, L2, L3, nothing like that. Everything is with the dev team. You have built it, you will run. So that was the concept. But over time, what happened is that that concept got diluted, and then people kind of started saying, now DevOps is dead, right? You might have heard some of those blogs saying DevOps is dead. So how many of you think today that DevOps is dead? Any of you think? Hopefully not, right? Because you're in a DevOps meetup. So that's a good thing, right? But many people, you will go and see that DevOps is dead. But the numbers, right? People might say many things, but the numbers are not saying that thing, right? So if you see numbers, the more people are saying DevOps is dead, the DevOps business value is increasing. This is the amount of stuff that is happening in the DevOps. So 2024, $20 billion industry for DevOps, including the tools, staffing. So DevOps is not dead. Same thing here also, we are saying DevOps is not going anywhere. Many of the organizations have really transformed radically. If any of you have read the Phoenix Project, very awesome book. I have it in my bookshelf also. So that's like, but at the same time, there is some problem. That's true, right? So it's not perfect. So why I'm saying there are some problems. So how many of you have heard about this thing called DORA? Some of you might have heard about DORA. Okay, DORA is a way to measure how good your DevOps is working. Because how can you improve something if you don't measure, if you don't know how it is today, right? You have to first know how you are today, then you can improve. So DORA has a few metrics, right? Some things that you can use to measure the performance and the quality of your DevOps team. So one of the metrics in DORA is lead time. What is meant by lead time? Lead time is the time it takes for something that you have developed to go to production. Okay, so let's say today, while sitting here, you develop something and you check in a code just now. And let's say it goes to production in 1 month, that feature. Then you have a lead time of 1 month. Simple, right? Lead time is the time it takes from when you are pushing in the code to the time it is, you can see somebody, user can see it in production, not in UAT, complete production. Okay. So if you see this, what it is showing, I know it's a small graph, but if you see, there are some people who has a lead time of minutes. What does that mean? You code now, in 2 minutes, you see it in the app. That's the awesome thing, right? That's what we all want, right? But at the same time, you have some which take more than 1 month. And some don't even know how much time it takes them. That is the situation. So you can see there is a wide difference, right? You can see there is a wide difference. Top performers are always doing awesome. They are mostly going to be, let's say, in minutes or something. There are some high performers who can at least have a lead time of 1 day. But then there are other people who are also doing DevOps. It's not that they are not doing DevOps. Everybody is doing DevOps today, right? But some are doing it better than others. Agree? That is what this is showing. Same if I go to deployment frequency. What is deployment frequency? How many times do you deploy every day? The more you deploy, the better, right? Because see, code, no matter you have written wonderful code and is sitting on a GitHub repository, who cares? Nobody, right? Unless and until the business can deploy that code, users can use that code and you can bring money to your business, your code is useless, right? It's just a fantasy and it's a hobby. Here also, if you see, there are people who can deploy on demand. You want no, they will deploy for you. Then there are people who only deploy, let's say, 3 to 4 times a year, which is obviously not good. You don't want to be here, right? You don't want your enterprise to be in this place. You want it to be in that place, either on demand or at least several times per day. I think you might have heard, right? Amazon deployed once 1800 times a day. It made a lot of news. So that's the level of stuff some people are doing, but not all, even though everybody is doing DevOps. Okay. Similarly, MTTR. MTTR represents kind of the average time it takes for your system to recover. Let's say something has gone wrong. I just tell you, man, something has gone wrong. How quickly can you recover the system? Let's say by deploying something which was the last version or whatever. Here also, there are some teams who can deploy, who can fix stuff within 1 hour. And then there are stuff who takes between 1 day and 1 week. So just imagine something has gone wrong and you are taking 1 week to fix it. How will your business run, right? The users you had will go away, run away to somebody else. Same thing with change failure rate. Again, the concept is same. What I'm trying to do all of this, you don't need to know all of this metrics. What I'm trying to say, guys, right? In this sort of meetups is good if you can take away 3 to 4 key takeaways. That's enough. And then you go home, Google and research and all of that. So one of the things I'm saying is that even though everybody is doing DevOps, some people are doing it better than others. That's what I'm trying to say here, right? Everybody is doing DevOps. Some people, the top performers, are doing it better than the bottom performers. Similarly, how much time does it take to create a new environment? So let's say today I ask you, let's say all of you are coding somewhere or the other. So now let's say you have deployed a new feature and you want to try it out on a new environment. How much time does it take to get it? Can you create the new environment yourself? Or do you need to talk to a DevOps engineer or some other team and they will say, okay, man, I'm busy, I will give it in 3 days. Right? Those kind of things happen, right? So here also, if you see, there are teams who can do self-service. So this is the best, right? I need an environment. I am a developer. I will just write something. An environment will spin up magically. I will deploy my code, test it, then shut down the environment. If I could have done that, I have no dependency on anybody, right? I could as many times as possible. But then if you see, environments are spun up by dedicated ops team. This is very common in the industry, right? You cannot spin up the environment. Nobody, oh, you are a developer, I will not give you access to the Azure portal. Very common kind of a thing you will hear from anybody, right? Which is very weird kind of a thing, right? I am deploying, I cannot see my stuff. Then what? How will I improve it, right? Then there are people who are saying can be created but need to be approved. Again, I will let you, but first you send me an email. I will approve why you need, what you need, how much time do you need, what is the cost, and all of that, right? So again, you can see there is the same pattern evolving again and again. Again, same concept, right? How do you provision infrastructure? Do you manage infrastructure via Terraform or something like that, where everything is in a code? Or you generate them on a case-to-case basis, which is the worst, right? You send a ticket, they will deploy a VM. Many companies still do that. Again, as you can see, the top performers are much, much better. They are saying provisioning is managed as code, whereas the low performers saying ops team will create them on a case-to-case basis. And obviously, all of our enterprises are somewhere in the middle. Right? My enterprise is also not in the top. I might be somewhere in the high and medium, but let's say Amazon, Spotify, right? They are at there. And then there is maybe some other very, let's say, non-digital sort of enterprise, which is here. So, as I said, right, what we can see again, and I'm emphasizing on this point again and again, is that there's a lot of difference in the maturity and the expertise between top performers and bottom performers, even though everybody is doing DevOps, right? So, what is the secret sauce? So, this survey that was done says that the secret sauce was this thing called platform engineering. I will explain what it is, but this was the secret sauce. The secret sauce was platform engineering. So, if you see, the top performers said, we have an internal developer platform. That is what helps us to be so fast, to be so quick, to deploy again and again. So that is the secret sauce. And I wanted to set up this contest because if I start suddenly and say, okay, guys, let's talk about platform engineering, you guys say, why? Why should I even listen to you, right? Again, it's a Saturday. Why should I waste my time on a Saturday listening to platform engineering? This is the reason. So top performing enterprises are saying there is the secret thing, sauce thing, let's say, called platform engineering, which is helping them. Okay, just a quick checkup, right? Just to see that you guys are. So how can we fix some of the current issues? Option A, DevOps is dead. We cannot do anything. Option B, we should hire higher paid DevOps engineers. And option C, embrace a platform engineering approach. Okay, hopefully now you guys are kind of in this area. See, and I will prove it to you, right? Why? What is this thing called platform engineering? And just to kind of keep all of you excited as well, right? On to the next part. At the end of the day, money matters, right? For me, for everybody. Why should a DevOps engineer also learn about platform engineering? I don't think there is much bigger driver than this. See the money difference between a DevOps engineer and a platform engineer. So platform engineers are getting paid more than DevOps engineers. End of story. Even in my company, because I hire both of them, right? So they are getting paid more than DevOps engineers, which I think is another impetus for all of you to know, okay, man, how can I know this thing and increase my salary? Right? Perfect. So again, end of section 1, very simple key takeaway message is DevOps is not dead at all. DevOps is increasing, but there are different sorts of enterprises. It's the maturity curve. Some people have been able to get the most out of DevOps, and some people have not been able to get the most out of DevOps. With this, I start with this concept of platform engineering. This is what I told you, right? Those high-performing teams are saying this is a secret sauce. So what is a platform? So let's say, for example, today in your company, you are building a new application and you need this logging / observability. What the earlier speaker was saying, right? What do you do? So one option is you build a logging solution yourself, obviously using the open source tools. You might use Prometheus, Datadog, whatever, right? But you still need to integrate it, make it secure. You need to buy the licenses, everything. You can do it yourself for your application. Very good. And you can go live with your application. Now, again, I am also in your company for another project. I also need to do the same observability. I also do the same thing. Again, so if everybody in the enterprise ends up building their own observability solution, who is the going to sort of suffer the most? The enterprise. So much duplication, right? Time to market also. So let's say compare this with another enterprise where you know there is an observability solution and you can just use it. It is completely certified by the enterprise security consultants. Everybody is saying that is the correct way to do. Everything is there. You just call an API and thing is done, right? That would have been awesome, right? In a way. Same goes for everything else. I'm not just talking about logging, observability, authentication. Again, all of our applications need some sort of an authentication, OR, JWT. You can build it yourself, or you can use some sort of a package that is already certified, hardened in the company. So the concept of a platform is, it is a set of reusable entities that has been already built within the company. You and everybody else uses. Only difference. Who is the consumer of the platform? Developers. The platform is being used by developers, not by business. So if I am a developer, I will use the components of the platform to build an application, and then that application might be sold to a business. Right? So we are all developing applications. You might be developing a payroll application. He might be developing a banking application, right? All of you are developing application for clients. These are all business-facing applications. But if I'm a platform team, my client is not the final client. My client is you both. I need you as the person building the payroll application and you as the person building the invoice application to use my set of tools and assets. Okay, so this is very, very important. And why? If I can do this over and over again, then you guys don't have to do the same thing again and your cognitive load will reduce. So you don't have to think about the observability. You know there is a team within your company who takes care of observability. They have made this solution. They are the platform team. I just need to talk to them and tell them, guys, I need observability in my solution. They will give me a small package. I will integrate it. Everything is done. That is secured. That is certified. I don't need to care about the licenses, procurement, nothing. I just use them. So that is the whole concept of platform engineering. And CNCF, Cloud Native Computing Foundation, you might have heard of them, right? They have also now taken a very, very keen interest in this concept of platform engineering. And as I was telling you, I'm part of the working group here for CNCF. So they are also saying it's a cross-cutting layer that ensures a consistent experience for acquiring and integrating capabilities and services for a broad set of applications. Again, this is also very important. The importance is that it should not be, it has to be self-service. It cannot be that again, to get this observability solution, I now need to send an email and I have to wait for 30 days. Then it defeats the purpose. Then it would have been better, I would have built it myself, right? So it has to be self-service, it has to be automated. I will share you some of the principles. But the overall concept is if you have this central developer platform, it's called a developer platform because the customer is a developer. The customer is not the final business. The customer is the developer. And if a developer needs something from to build his application, rather than have to think how to take that thing, he will basically. Now you might say, okay, this is not AWS or Azure. I today use them. Yes, Azure and AWS are, that's why cloud computing platform. They are also platform, but they provide the basic cloud infrastructure. They will provide you Azure function, AWS Lambda, all of those, right? Now you will take all of the cloud stuff and build a little bit higher abstraction on top of it. Because an observability solution is not just using log analytics, right? Or using CloudWatch. We all know that, right? It's much more complicated, right? That's why take the cognitive load. So all of that things will be implemented here in a platform. And once I give you examples, you will understand. So then what is platform engineering? The concept of building a platform is platform engineering. So now in companies, you have two types of teams. You have the normal teams who are basically working for business, building business facing application, that is 90%. And then you will see there is a 10% team who is building platforms. So their consumers, their client, the other developer. They don't care about the end business that much. They care about the developer. If the developer can use them very easily, then the developer will use them to build application that will then use their clients. So that is the difference, and I will explain that difference in a little bit. So maybe I will show this view a little bit, which will help you understand this, because this is very important. Again, as I said, right, in all of this sort of meetups, if you can understand 2 to 3 key things, that is the most important thing. So see, there is a platform team. These are completely separate team. Then there are product teams. These are the teams normally which are building business-facing products. These are products which will be sold to clients or internal products also, but these are business products. These are payroll product, invoice product, shopping product, those kind of things. The platform team doesn't care about that. The platform team is giving you caching, observability, logging, monitoring, compute, network, security, auth. Those kind of things are here. So the platform team is building technical assets that then product team will use to build their product. Understood this concept? So what is the, now you will say, man, what is so special in that? The specialty is, as I said, every single product team now does not have to build the same thing again and again. Number one, because all of them can use this underlying platform. You might say, okay, then this is, as I said, this is Azure only. All of them are using Azure. But we all know that just using Azure is never enough. Then what we are doing, right? Then everybody could have just used Azure and gone. So what is the difference? Because Azure gives you the base infra, but there are many other things you need. So can anybody just say that I will just use log analytics, I'll just use a VM? No, a VM is just an, Azure will give you a normal VM. But in an enterprise, a VM will have this antivirus tool, right? That sort of encryption. These are the basic softwares that will be installed on them. Who installs them? The platform team. So the platform team takes the base thing from the cloud provider. They will never replicate what the cloud provider is doing. This is built on top. This is backend infrastructure. This is AWS, Azure, or Google. So they are using the same cloud platform, but then they are making a much more technically usable enterprise grade, which is ready for your enterprise assets here, and then you just take those assets and build your own product. Same thing is actually shown here also. Same concept. See, infrastructure as code or whatever you are using, right? This will all be used by the platform engineering team. They will use it and build their products. So what are some of the products of platform engineering tool? As I said, right, a logging framework could be a product. A file transfer, something could be a secure data movement could be a product. Data ingestion could be a product. So those are stuff that the platform team will do. Then the platform team will expose them as an API. And your business team, who is application developer, who are building business facing features, this is what the client needs. Right? The client will come to you and say, I need a payroll application. Client doesn't care whether you are using Redis cache or you are using log search, whatever you are using, they don't care, right? They need the final thing. But you still need them, right? You need to know, okay, should I use Redis cache? Should I use, for example, for vector databases, right? Should I use Pinecone? Should I use, let's say, PICE? Should I use whatever, right? Quadrant. You don't need to care anymore because you know the platform team has given you a vector database that is secured, that has been tested, that has been tried, that has support, full support, everything. They have good patterns, everything. So you just need to call the platform team, get the vector database from the platform team and use it in our application. That is the overarching concept. So there are two teams. Again, I'm repeating, there are two teams within enterprise nowadays. There are many more. There's a book called Team Topologies. If any of you guys are interested, you can read it. That explains this in much more detail. Very, very popular book, right? One of the best sellers. But for your purpose for this session, there are two teams. Take away with this. There is a team where most of you might be working on, which is the application development team or DevOps team, whatever we call it here. And then there is a team called the platform engineering team who are building technical offerings. All of the application developers are the customer of the platform. Okay, very cool. These two slides I'm just keeping in interest of time. Now, one of the things is that I am saying platform engineering is important. Why should you believe me? Right, I can say anything, right? But Gartner is also saying the same thing. So Gartner releases something called top strategic technology trends every year. So you know Gartner, I think, right? They're like a industry thought leader, right? They have they talk to many CIOs, CTOs. They predict 50 years in advance. So they are saying the fourth most important thing today is platform engineering, right? So that is very important, and they have their own hype cycle. And the most important thing that platform engineering does is it reduces cognitive work. What do I mean by that? See, when I started my career 14, 15 years back, right, I used to just go into my laptop and write code. Nothing else. I did not care about this DevOps, Terraform, infrastructure, observability, nothing. Every day I used to wake up, I used to go to office. We used to write them in Java, right? I used to work in Samsung Research. I used to open JetBrains ID, write my code, Eclipse, and push it to the source control repository, come back home and do whatever I want, right? That kind of a thing. But now you just imagine today's developers. Observability, distributed tracing, Prometheus, GitHub Action, Terraform, Ansible, crazy kind of cognitive load. So this is what is called cognitive load. Cognitive load means the pressure that is being put on every single developer today. So today this concept of full stack developer, right? Every company, what does mean? That you have to know everything, which is very, very complicated, right? That's why if you see today, over time, the cognitive load has increased. Earlier, people were developing monolith application. Developers are happy. Okay, I will come, code, go home. But now microservices, okay, this thing is calling that thing. Okay, what do I know about it? How do I trace it? I have to put this trace ID in every single API call. Crazy kind of stuff is happening right now, right? So, and it's only increasing. But platform engineering can reduce this cognitive load. Because now with this, you don't have to think about a lot of this, right? The distributed tracing is taken care of by the platform team as long as you use that component. So the overall idea of platform engineering is also to reduce cognitive load of developers. That's why it's so popular today, and that's why Gartner is saying it is the fourth most important thing. But it's still a relatively new concept. That's why I said, right, this is still relatively new. We started our platform engineering journey roughly around 2018-19 in my company. Right, as you can see, most of the companies are, let's say, 6 months to 1 year, only a few 3 to 5 years, and only a few is 13.42% is 5+ years, which is very, very, let's say, young sort of a concept, right? But things are changing fast. That's why it's important for you all to at least know about this, so that next time you go to an interview, next time somebody asks you something, you at least know what this concept is and you can go home and research it. So if you see today, 55% organizations are already on board to kind of onto a platform. They're already saying, this is a survey that Google did, right? Across the surveyed, let's say 100, 200, 1000 companies, and 90% are planning to expand the adoption. So if you see here, most of the people, right, everybody this survey, only 8% said, I have no plans to implement platform engine. They're like, no matter what happens, I will not do that, right? But all of the others, the rest 92% are somewhere in the journey. Some are very advanced, some are a little bit advanced. So out of us, right, let's say we have 100 people here and all of us get 100 jobs. There is a chance 8 of us will land up in this company, this sort of companies. There, even if I don't know platform engineering, I'm okay. But for the rest of us, 92, it's good to know platform engineering because your company is already onboarded onto platform engineering, right, in some way or the other. So, okay, quick check again. Why should you learn platform engineering? To get better salary, to reduce the cognitive load of developers, to improve the DORA metrics like velocity, MTTR, all of the above. Perfect. Good. Thank you so much. So again, key takeaway message. What I said here is platform engineering is the way an enterprise can get most out of their DevOps investment. DevOps is not dead. DevOps engineers will stay. Everything is cool. DevOps is going good. But platform engineering is what you need now. Right now, the cognitive load on developers is such at a high level that it is becoming crazy for them to continue. Right, so many things. Platform engineering is the solution. That's why I told you that Gartner is also saying, not only me, Gartner is saying this is the fourth most important thing. And I showed you a survey where out of 100 companies, 92 companies are somewhere in their journey, but it's a still relatively new. That's why I said I'm part of the CNCF platforms working group. We're still coming up with research papers and all of that. It's a good time to be there. It is not like DevOps where everybody already knows everything, everything is done. This is still relatively new. It's a good time to be a platform engineer, especially because they also pay more. That's also good sort of a thing. Now, coming to this concept, after all of this, I told you, right? You might say, okay, man, what is the difference, right? I think this is kind of smelling like DevOps, right? What is the difference, right? I also used to do this. So, if you see that high level, the thing is differences. And again, I will not go through each and every one of this, but a DevOps person will use the tools provided by the platform to build applications. This is the whereas the platform person will build those tools. You understand the difference? Hope? Because that is the most important thing, right? The difference between a DevOps engineer and a platform engineer. A platform engineer is basically a product-oriented approach. They're kind of like a product team within the organization. They're building technology assets that the rest of the developers will use. So a DevOps engineer might end up using what a platform engineer has built. And but the platform engineer will never go and suddenly go to a business facing application and start working on DevOps. I mean, they can technically the skill set is quite same, right? But the concept is different. A platform engineering group within any organization, for example, the organization where I belong, I am in the platform engineering group. We get paid roughly 30% more than the rest of the org, roughly. That's why it becomes very difficult for us to switch to the rest of the org. Right. So let's say something goes wrong and we try to go to another part of the org. They say, yeah, your salary is too much. We cannot afford it. Right. That's how the situation is. Because we are building the cutting edge sort of tools that the rest of the org will use. And the rest of the org is developers, designers, let's say DevOps engineers. They will use those tools and build. That is also very important. I told you, right? That's a $20 billion industry. But this is now even more cool, so to speak, and paying more and much more interesting. And this is why I'm saying that it makes sense, right? That DevOps, from a DevOps engineer, once you are, let's say, 3, 4, 5 years, thinking about moving to platform engineering, thinking about that as a concept, learning about it, all of those. And most important thing is that it's not like I have to do DevOps or platform engineering. I hope I clarified that, right? Both are there in the company. They will be in the company. The platform engineering is the internal part. They are never exposed to the final business as such. They are building internal technology assets, reusable artifacts, all of those things. And then the DevOps engineer will use them. The developers will use them to build business facing applications. But at the same time, as I said, right, it's a paradigm shift. So it's not like every single company, okay, I was DevOps today. I put a sticker on the, oh, I am a platform engineering. No, not like that. These things will not work, right? So what we have to do is we have to also align with this fact that there has to be a maturity curve. On day one, I might be just at this level. So, for example, my interfaces might be custom process. My operations will be by request. But let's still come up with a platform. Over time, I will be in this process. So this is called a platform engineering maturity model. There's a white paper link I have given. There's a very nice YouTube video which explains this maturity. Everything is about maturity. Let's say we go to gym today, then, right? Today, if I go to gym, I will not have a six-pack abs tomorrow. Same sort of a concept, right? I have to work. I will have to take small steps. Same thing. You can move from provisional to operational to scalable to optimizing. Same concept, right? As I said, operations by request. So initially you might set up a platform, but you don't have automation. People have to call you and then you set it up. So then it is by request, but then it's centrally tracked, centrally enabled, and then you finally provide it as a managed service. This is kind of like the holy grail of platform engineering. Amazon, those companies I was showing, we are doing the most out of the DevOps, they are at this stage, right? So we have to move from the left to the right over time. Finally, a last quick checkup. Is platform engineering and DevOps same? Hopefully no. Perfect. Good. Thank you so much again for coming on a Saturday and spending time with us. I hope you have a great rest of the day. Thank you.